Cancer, a cellular plague since the dawn of humanity. Film 2, Understanding and Fighting. At the dawn of the modern world in the early days of the 20th century, cancer remained shrouded in mystery. Surgery sometimes worked, but it was hit and miss, and no one knew why. As for liquid cancers such as lymphoma or leukemia, there was still nothing to be done. Paris, 1895. The physicists and married couple Pierre and Marie Curie discover radium, an element that emits rays with the peculiar ability to penetrate matter. What if these rays could destroy cancerous tumours? The first tests were quickly conducted, and the results left no room for doubt. Radiotherapy was born, offering a new glimmer of hope. The next would come from the field of chemistry. For centuries, chemistry and biology had been entirely separate disciplines. But in the course of the 20th century, an idea began to take hold. What if chemical molecules also had the power to target cancer cells and cure diseases? A key breakthrough in this field came with the Second World War, more precisely, a military disaster. On the 11th of September 1943, the Germans launched a surprise attack on the port of Bari in Italy. One of the ships destroyed was the SS John Harvey, which held a secret cargo of over 1,000 mustard gas bombs for the Allies. The gas spilled into the harbour with catastrophic results. More than 600 men were injured and 83 died from exposure to the gas. But doctors treating the victims made a stunning discovery. Under the effects of the mustard gas, the victims' white blood cells had been virtually annihilated. The gas appeared to have targeted cells of a particular type, preventing them from replicating. It followed that if chemical molecules could selectively target certain cells, perhaps they could be used to fight cancer. And so the horrors of the port of Bari gave rise to a new treatment idea, using mustard gas to fight liquid cancers. Chemotherapy was born. It was the start of a frantic race against time to find the most potent poisons. Led by scientists such as Sidney Farber, the father of cancer chemotherapy, the quest for cytotoxic molecules would draw on poisons from the Madagascar periwinkle, toxic mushrooms, the adrenal glands of animals, folic acid antagonists. Some patients went into remission. The first victories had been won. Unfortunately, these successes came at a high cost. The poisons attacked all cells that reproduce rapidly in the body, not just cancer cells, but also those of the hair, nails, or reproductive system. The subjects were cured of their cancer, but suffered devastating and sometimes fatal side effects. Science continued to progress, however, and with it our understanding of living things. In 1953, Rosalind Franklin, Francis Crick, and James Watson discovered the double helix structure of DNA. Since the 30s, the ingredients of DNA, phosphates, sugars, and nitrogenous bases had been known. But the realization that DNA is the code that governs protein synthesis did not come until the 1950s. So how does protein synthesis work? DNA is our architect. It produces a blueprint, known as messenger RNA, which, when deciphered by the right workers, very specific enzymes, allows a house to be built. A protein. Any mistake by the architect will have an effect on the house. If something is wrong with the DNA, the architect, this will affect the construction of proteins too. We were finally beginning to understand cancer. Whereas we had previously thought that the answer lay in treating organs, we now knew that cancer affects a fundamental mechanism of life, cellular reproduction. As our knowledge grew, a third ally emerged, our own immune system. What if the most effective weapons against cancer were those made internally, relying on the body's own defense system? This was the hope of immunotherapy.